So here we are, 6.4a, polynomial equations continued and the fundamental theorem of algebra. Okay, so one of the things that we've done over the past however many years you've been taking math is you've learned how to divide polynomials. For example, if you had x to the fourth plus 6x cubed plus 5x squared minus 4x plus 2, and you want to divide that by x plus 2. You'd have this whole stinking hour and a half ahead of you as you go and put x cubed up here and get x to the fourth plus 2x cubed, subtract, and you got 4x cubed. Bring down the 5x squared. X goes into that. 4x squared. And your life just goes by because you're spending it all doing these kind of problems. Well, there is another method to solve these, and it is called synthetic division. Some of you might have had a teacher in the past that loved you enough that they taught you synthetic division. I mean, it is good to learn this method as far as putting you in a place where maybe you need suicide prevention or something after doing a lot of those, but really there's a lot of work there and it's hard, but it is good to learn because there are some times where you're going to need it. Need to be able to do it. Okay, the bottom of the page, 467, gives you the steps to synthetic division. You can go ahead and read through those, but I would suggest you just listen and watch me do this math problem right here using the synthetic division. All right, so what we're going to do is we're going to look at our x plus 2, and this only works at this point with expressions like x plus 2, x minus 3, x plus 17, those kind of things. If you have a number in front of the x, like 2x plus 2, or an exponent on the x, not going to work at this point. Okay, so we're just going to do with x plus 2. So what we're going to do is make a little box, and we're going to take the 2 and we're going to change its sign, no matter what it is. If it was a negative sign, it'd be a positive sign in our little box. Then we make a list of all of the coefficients for each one of these terms. So there's 1, 2, 3, 4, 5. Okay. First of all, these all have to be in order. So 4, 3, 2, 1, 0. Okay. And so let's go ahead and write those. First number is a 1, then a 6, then a 5, then a negative 4, and then a 2. And then you put a space and you draw a line. We bring down the 1. We multiply it by negative 2 and put that answer here. Then we add. Then we multiply the negative 2 times the 4. Then we add. Negative 3 times the negative 2. Then we add. Negative 2 times the 2. Negative 4. Then we add. So notice there isn't anything really scary. I mean, in subtraction, when we are doing this up here, we are subtracting everything. The nice thing about synthetic is you're adding everything, okay? And you get just a list of numbers, okay? You will deal with decimals and fractions at times, but in this initial state, not too bad. All right, so once we're done with that, we take our original problem right here, and we notice that we started with a 4 as the exponent. Well, when you're doing synthetic division, your answer is going to be 1 less than the highest exponent. So this is going to be 1x cubed instead of 4. This is going to be 4x squared minus 3x plus 2. Okay, so notice we went from 4, 3, 2, 1 to 3, 2, 1. Okay, but what do we do with this negative 2? That negative 2 is our remainder. And our remainder is that negative 2 over this x plus 2 that we were dealing with over here. And you are done. That is it. Okay? You did not have to spend hours and hours doing all of this, taking chances for mistakes. You just used this right here. Okay, so again, you can use those steps to figure it out, or you could just listen to what I said. Okay, so let's go ahead and do another one. The book doesn't give us any other examples, so I'm going to go clear over to the homework assignment, and we're going to do one there. Okay, let's go ahead and take number 3. So we're going to write, we've got the x minus 1, so we're going to make a box, and we're going to put a positive 1 in it. Okay, we change the sign. So you take the second, this a binomial, and do that. And then in front of that, you've got 2x to the 4th minus 3x cubed plus x minus 7. We're just going to take the numbers. Okay, now let me pause here. I'm going to write out what they gave us there. They said 2x to the 4th minus 3x cubed minus, or plus x minus 7. Okay, notice we went 4, 3, we skipped the 2 and went to the 1. We cannot skip that. We're going to have to erase this, and we're going to have to write plus. We've got to have an x squared in there, but we can't just add an x squared, so we make it a 0x squared, so it really has no value at all. Then we put our plus x minus 7. Okay, so that being the case, then, that won't go away. We're going to put our 0 right there. Okay, so this is the 0x squared, and this is the 1 that goes in front of there, and the negative 3 that goes there. All right, so we draw our line, giving us ourselves a space, put a 2 there. 2 times 1 is 2, add. Negative 1 times 1 is negative 1, add. Negative 1 times 1, negative 1, add. 0 times 1 is 0, add. Okay, so we end up with 2x cubed, since that's 4, minus 1x squared minus 1x plus 0, minus 7 to the, what was it, x minus 1. Okay, then you can get rid of this and get rid of the 1's there, and you end up with 2x cubed minus x squared minus x minus 7 over x minus 1. So you get that. Okay, so that's synthetic division. Just wanted to make sure I went over a couple of those instead of just the one there, and give you a little bit more practice before we jump into solving an equation with synthetic division. Okay, example 1. Okay, so before we go into this one, I do want to make mention, and the book doesn't mention it. In fact, no, I guess they do mention it in the section preview. But one of the things about synthetic division, or any kind of a division, is if you do not have a remainder, then that means that what you divided is actually a factor. Okay? So what I mean is, if we were dividing this by, say, x plus 2, okay, and we did our division, and we ended up with no remainder, then that means that this goes evenly into that. It means it's a factor of that. For example, if we just were going to use a regular number like 9, what is a factor of 9? What number goes evenly into 9? 3 does. So 3 is a factor of 9. When I divide 3 into 9, I get 3 with no remainder. Same thing here. If I divide this into this and I get no remainder, then this goes evenly into this. Okay, so that's pretty much what I want to mention there is if it does go evenly, it is a factor. And that is a very, very important thing to remember. And I don't know if it's in this section, but later on that will be an important thing to do, is be able to do synthetic division real quick so that you can find out if the stuff you're looking at is a factor. Okay, so example 1. If x equals -2 is a solution of this, that means if I can plug -2 in here and get 0, that means that is one of the solutions. Because this is a 3, there's probably a couple more solutions in there, okay, up to 3. There's no more than 3 solutions because you can never have more solutions than the highest degree of the equation. But there could be 1 or 2 more solutions here. -2 is not the only one. So, how do we do that? Well, if x equals -2 is a solution, then x plus 2 is a factor. Because if we were dividing this into this, and if -2 was an answer, that means if we put -2 in here and we put 1, 8, 21, 18, okay, let's just go ahead and try this. Let's see if this is actually an answer. Because I got 0 here at the end, I don't care what this stuff is. Doesn't really matter at this point. All I wanted to do was see if I got a remainder. I did not. So therefore, -2 is an answer here, and x plus 2 is a factor of this. That means that x plus 2 times something is going to give me this right there. Okay? So, I went ahead and showed that if -2 is one of the answers, then x plus 2, the opposite sign here, is going to be a factor. So that being the case, what in the world are the numbers besides x equals -2 that could possibly be answers to this? And that's what we're trying to find out. Okay, so I divided this thing by x plus 2. And my final answer is going to be x squared plus 6x plus 9. This here is what I got from right here is what's left after I took an x plus 2 out. Okay, by dividing it by -2 by its opposite, I found out that this is a factor of this. This is also a factor of this, because this times this gives me that. Well, this here isn't simplified all the way. Let's go ahead and simplify that some more. So I'm going to leave my x plus 2 alone, which gives me an x value of -2, like they gave me at the very beginning. So let's go ahead and factor that. Three times 3 is 9. 3 plus 3 is 6. Okay, so this times this times this gives me my original problem again. Okay, so if x equals -2, x equals -3 here, and x equals -3 here. So what do I have? I have the 3 numbers that work for this problem right here. Those are my 3 solutions: -2, -3, and -3. Okay, since -3 occurs twice, it has a multiplicity of 2. Remember, we talked about that earlier. It's got a multiplicity of 2. So actually, I only have to write my answer as x equals -2 and x equals -3. Which means the graph crosses at -2 and 3. So if I were to graph this thing, I would have a graph that 1, 2, 1, 2, 3, 4. -2 and 3 means it would come up here and then go down and then back up again. Okay, because it's an x cubed, it's going to have that kind of wonky shape there. Okay, so it's a lot easier to do the synthetic division in order to find out what your factors are. Okay, a lot easier. Okay, so that's it for 6.4a, and we'll continue with 6.4b.